Remember that chemistry is an experimental science. While it's fine to talk about how to determine the chemical formula of a compound in theory, how do chemists know if the formulas they predict are correct? First, they would have to be able to determine the chemical formula of a compound experimentally before they could ever devise a theory that matched their experimental results. While it's fine to predict the chemical formula of a known compound, very often the chemist is faced with the task of figuring out the chemical formula of a compound that isn't known. How can this be accomplished? If you were given a sample of some unknown compound, how can you determine what compound it is? That's what we'll be talking about in the next two lessons. It turns out that if the compound can be separated into the various elements that make it up, and these elements can be identified, then with a simple laboratory balance, the chemical formula of the compound can be determined. The first step in this process is to determine the mass percent composition of the compound, sometimes just referred to as percent composition by chemists. That's where we're going to start this lesson. So what do we mean by the mass percent composition of a compound? And remember, we said that very often chemists simply refer to this as percent composition. Well, qualitatively speaking, the mass percent composition or percent composition is the percent by mass of each of the elements in a compound. Now, if we want to actually get a number, that is, calculate the percent composition for each of the elements in the compound, then this is the way we do it. We would say that the mass percent of a given element in the compound, let's say element X, is simply the ratio of the mass of element X in the sample of the compound that you have, divided by the total mass of the sample of the compound. And of course, we've got to multiply our answer by 100% to convert our decimal or fraction into a percent. So why, you might ask, would we want to determine the mass percent composition of a compound? Well, first and perhaps most obviously, it gives us a way of expressing how much of a given element is in a compound. So for example, if we have a compound consisting of hydrogen and oxygen, and we can say that the compound is 80% oxygen by mass and 20% hydrogen by mass. This provides a way of expressing how much of each of those elements exists in the compound. But secondly, and perhaps more importantly, finding the mass percent composition of each of the elements in the compound is really the first step to determining the chemical formula of the compound from experiment. And once that chemical formula is known, then we have a way of identifying the compound. Alright, so as I was saying before, very often the identity of a compound is unknown, in which case we don't know the chemical formula of the compound since we don't even know what compound we've got. Finding the mass percent composition is a first step to being able to determine the chemical formula of the compound and ultimately identify it. Very often, experimental separation techniques can be performed on the compound to separate it into its various elements. So let's see how we can go about calculating the mass percent composition of a compound for such an experiment. Here is a three-step procedure to follow. The first step is to use the data given to determine the mass of each element in the compound as well as the total mass of the compound. In some problems, the masses of all the elements in the compound will be given, in which case you can add the mass of all the elements to get the total mass of the compound. In other problems, the total mass of the compound may be given, yet the mass of one of the elements in the compound will be unknown. Here you'll have to use the massing by difference technique to determine the mass of the unknown element, okay, by subtracting all of the given masses, okay, the known masses, from the total mass of the compound. So once the mass of each element in the compound is known, as well as the total mass of the compound, okay, you can then simply use the definition, okay, to determine the mass percent composition of each of the elements in the compound. And so remember, we talked about this previously. By definition, the mass percent of a given element in the compound is simply that ratio, the mass of that element divided by the total mass of the compound, times 100%, of course. And finally, step 3 is provided here to serve as a check, an important check against errors. Okay, you know that when you add up all the mass percents of each of the elements in the compound, they'd better add up to 100%. Okay, and if for some reason they don't, then you know you've got an error in your calculations somewhere. So let's look at a couple of examples where we calculate the mass percent composition of a compound from experimental data. In our first example, we're looking at an 8.20 gram piece of magnesium combining completely with 5.40 grams of oxygen to form a compound. We're asked to find the percent composition of this compound. So in this example, we're given the mass of each element in the compound. So in our first step, we can add the mass of each of these elements to determine the total mass of the compound. So the total mass of our compound will be, okay, the 8.20 grams for the magnesium plus the 5.40 grams for the oxygen to give us a total of 13.60 grams. So remember, in step 1, we need to determine the mass of each element as well as the total mass of the compound. Okay, we have now done that. Okay, the second step, we're going to use the definition to calculate the mass percent of each element in the compound. Starting with magnesium, okay, we're going to take this ratio, that is the mass of the magnesium in our sample, okay, divided by the entire mass of the sample. Okay, we said that in our compound, 8.20 grams of it is magnesium. Okay, divide that by the total mass of the compound, which we said was 13.60 grams from step 1. We'll multiply that by 100% and we'll get, okay, 60.3%. Next, we will do the same process for the other element, which is oxygen. That is taking the mass of oxygen in our sample divided by the total mass. Okay, oxygen has a mass of 5.40 grams divided by the total mass, which once again is 13.60 grams, multiplied by 100% to get 39.7%. And finally, we will check to make sure that the mass percents, okay, for all of our elements add up to 100%. Okay, when we do this, 60.3 plus 39.7, does it add up to 100%? Yes, it does, says Timmy the test tube, so we are good to go. That's a good check, okay, to see that our calculations are correct. All right, so let's take a look at a second example here where we calculate the mass percent composition from experimental data. We're told in this problem that when heated in air, 4.89 grams of zinc combines with oxygen to form 6.09 grams of zinc oxide. We're asked to find the percent composition of this compound. So in this problem, we're dealing with the compound zinc oxide, which is a common component found in sunblock, as well as the active ingredient in skin creams used to heal rashes. Okay, the first step, as always, we need to find the mass of each element in the compound as well as the total mass of the compound. Now you recall in the last problem we were given the masses of all the elements in the compound, which we then had to add to get the total mass of the compound. In this particular problem, we are given the total mass of the compound and the mass of one of the elements. Okay, so we're going to need to find the mass of the other element, okay, which is oxygen. So we can simply mass by difference here. So we'll subtract the mass of the zinc from the total mass of the compound to get the mass of just the oxygen. And when we do the number crunching, we get 1.20 grams. Now that we know the mass of all the elements in the compound as well as the total mass, we're ready to calculate the percent composition for each of the elements in the compound. Starting with the zinc, okay, we take the ratio of the mass of zinc in the sample to the total mass of the sample. Okay, here the zinc is given to be 4.89 grams. Total mass of the compound 6.09 grams multiplied by 100%. We get that the compound is 80.3% zinc by mass. We'll do the same for oxygen, the other element in the compound. Okay, taking its mass, we figured out in step 1, the 1.20 grams, dividing by the total mass of the compound. Once again, multiplying by 100% to get the 19.7% oxygen by mass in this compound. And finally, we can perform our check, make sure that all the percents add up to 100%. Okay, 80.3 plus 92.7, does it equal 100? Yes, says Timmy test tube. Okay, so we can be fairly confident that we did our calculations correctly here. So far we've looked at how to calculate the mass percent composition of a compound given information about the masses of each of the elements in the compound. This is what kind of information you would typically get from doing an experiment where you can separate out the various elements in the compound. But it may be the case that if the chemical formula of a compound is known, you may want to find the mass percent composition of each of the elements within the compound. So here's a step-by-step procedure on how to do this. The first step would be to determine the molar mass of the compound from the chemical formula. Once that's done, you can determine the mass percent of each element in 1 mole of the compound as follows. The mass percent of a given element, let's say X, would simply be the mass of element X in 1 mole of the compound, okay, which can be determined from the periodic table, divided by the mass of 1 mole of the compound, which is simply the molar mass, which you've also figured out in step 1 from the periodic table. And of course, we're going to have to multiply by 100% to turn this decimal or fraction into a percent. And just like in the last set of problems we looked at, you can always check and make sure that your mass percent for all your elements add up to 100% to prevent any sort of calculation errors. Alright, so let's take a look at a couple of examples to see how we can determine the mass percent composition when the chemical formula is known. Alright, in this first example, we're told that acetylsalicylic acid, more commonly known to us as aspirin, has the chemical formula C9H8O4. We're asked to calculate the percent composition of each element in the compound. So the first step is to determine the molar mass of the compound from the chemical formula. And we'll use the shortcut, the shorthand notation, where we don't include all the units here to save ourselves a little bit of time. So from the chemical formula C9H8O4, we see that we have 9 moles of carbon atoms plus 8 moles of hydrogen atoms plus 4 moles of oxygen atoms in 1 mole of this compound. So from our periodic table, 9 times the molar mass of carbon, 12.01 grams per mole, plus 8 times the molar mass of hydrogen, which is 1.01 grams per mole, plus 4 times the molar mass of oxygen, okay, about 16 grams per mole. We do the number crunching, add that all up, and we get 180.17 grams per mole. That's the molar mass of this compound. The second step then is to determine the mass percent of each element in 1 mole of the compound. So in 1 mole of acetylsalicylic acid, we have 9 moles of carbon atoms. So starting with carbon, we've got 9 times the molar mass of carbon. okay, which is 9 times 12.01, divided by the molar mass of the entire compound, 180.17. That gives us about 59.993% carbon by mass in aspirin. Okay, turning our attention to hydrogen. Okay, we've got 8 moles of hydrogen atoms in 1 mole of the compound, so 8 times the molar mass of hydrogen. Okay, and that at the end of the day gives us a mass percent composition of 4.48% hydrogen in acetylsalicylic acid. And finally, with oxygen, we've got 4 moles of oxygen atoms in the compound. So 4 times the molar mass of oxygen divided by the molar mass of the compound of 180.17 gives us 35.52% carbon by mass in this compound. And as always, we'll just to check against errors, we'll add up all the percents and see if we get 100%. When we do that, we get 99.993%. Yeah, okay, that's close enough when rounding errors are taken into account, says Timmy Test Tube. So yes, that's close enough to 100%. We can have great confidence that we did our calculations correctly. All right, so we'll take a look at one last example where we calculate the mass percent composition of a compound given the chemical formula of the compound. So in this example, we're told that lysergic acid diethylamide, more commonly known to the counterculture movement of the 1960s as simply acid or LSD, is considered a hallucinogenic drug and has the chemical formula C20H25N3O. We're asked to calculate the percent composition of nitrogen in the compound. So here we're not asked to find the percent composition of the other elements, that is carbon, hydrogen, and oxygen. In this problem, we're simply asked to find the percent composition of one of the elements in the compound. So we need to start by determining the molar mass of the compound, that is, find the mass of 1 mole of the compound given its chemical formula. So using the shortcut approach, once again, in 1 mole of the compound we have 20 moles of carbon atoms, 25 moles of hydrogen atoms, 3 moles of nitrogen atoms, and 1 mole of oxygen atoms. From the periodic table, we'll substitute in the molar masses of each of these elements. Okay, and multiplying by these coefficients here, we will do the number crunching, and it turns out that 1 mole of acid has a molar mass of about 323.48 grams. With that given, the second step is to determine the mass percent of the given element. We're asked in this problem to find the mass percent of nitrogen in 1 mole of a compound. So in 1 mole of lysergic acid diethylamide, we have 3 moles of nitrogen atoms. So multiplying the molar mass of nitrogen by 3 gives us the total mass of nitrogen in 1 mole of the compound. And of course we have to divide by the molar mass of the entire compound. So nitrogen has a molar mass of 14.01 from the periodic table, so we multiply it by 3, divide by the molar mass of the entire compound, multiply 100%, and we get about 13%, 12.99% to be exact. So lysergic acid diethylamide, LSD, is about 13% nitrogen by composition. Now here we say as a check, make sure that the mass percent of all the elements add up to 100%. Well, unfortunately, as Timmy Test Tube is telling us here, that without calculating the mass percent of the other elements in the compound, there's really no way to check. And since we weren't asked to do this, we cannot use this great check against errors here. We're going to have to trust our calculating abilities on this one.